Hey guys, what's up? Welcome to another video. Today we'll be talking about FMIs or functional mockup interface. Now, this will be a very, foundational or very basic understanding of what an FMU will be. If you are someone who has come to watch this video thinking this will be more in-depth one, then I think you're in the wrong video. But don't worry, I'll mention the links for all the in-depth videos on FMIs down in the description, so you can definitely go check them out. But if you're okay with just having a base level understanding, this video is for you. So with that said, let's get into the video. Now when I talk about model based system engineering or control systems related software, the first software which comes to mind for many of you would be Simulink, right? Because Simulink has this industry academia collaboration where it gives to academic licenses to all the students in colleges, and it is a very powerful tool. You can do a lot of stuff with it. But the thing is, once you move from academia to industry, of course you don't retain the same license Simulink, but at the same time, it's not necessary that you'll be using Simulink in the industry also. It depends on what company you work in and whether it has any partnership with MATLAB. But if Simulink is not your first choice in your company, might as well there might be other softwares also, like Open Modelica, you have Activate, you have, if I'm not wrong, LabVIEW, NI LabVIEW. These are also control systems, or model-based system engineering softwares, and companies prefer to use one particular software because it works well for them and suits for their necessity specifically. Now, let's say we had a scenario where two companies are collaborating to work on a single project, but one team from one of the companies is good in using Simulink, but the other team from the different company is good in working with NI Now, how are these two gonna collaborate? That's the question. Because they don't have a common software to interact with each other, right? They don't have a common software where they can share their models, get review, get opinion, or improvise on the software, or improvise on the model, or anything like that. But to overcome this problem, we needed something which is a more general format. Okay, if not a general software, at least a general format which can be shared between these two teams, and that's where FMU comes in. Okay, FMU is this kind of is a kind of a general format of a file which contains all the necessary details of the model, no matter what software is developed. Okay, be it Simulink, be it NLabVIEW, be it Open Modelica, any modeling software. It contains all the data or all the functions which have been modeled in particular software down in C functions, and this format can be imported into any of the MBAC softwares or model-based system engineering softwares, because it is a widely accepted standard also. The latest FMI standard which has come into practice is FMU 3.2, before which you had FM 2.2, FMI 2.0 and FMI 1.2. FMI 2.0 is still the preferred standard. We are still in the transition phase towards FMI 3.0. But FMI 2.0 has all the necessary features with which we can work easily, okay, across any of the MBAC softwares. Another reason why we use FMIs is for confidentiality purposes. Say I am an independent creator. Okay, I work on a contract basis, and I want to share my models with my client, but I don't want my client to get to know what kind of setup I have used within my model, or what kind of functions I have used inside it. Okay, because it's possible that he might use it for his or her own purpose, and I might not get any credit for it. Okay, that might happen. So to overcome this problem also we have FMI used. Think of it like, having a black box. Okay, so basically you put your model into this black box called the FMI, and this black box has these holes where you can take out the inputs and the output ports. Okay, so the input ports you have on one side and the output ports are on the other side. You cannot make sense of what is inside that box, but by connecting the right inputs to the right connections, you can get the correct output. Okay, your whatever output you're desiring, right, you'll get that same output. The added benefit is no one knows what is going inside that box, that's all. So for privacy also FMI can be used. Like I said, I'm not going too much into the conceptual details, but I would like to share with you a few aspects of this, FMI zip file format, so that we can just get the gist of what's going on inside. How are we able to share this data across different teams without actually undermining the security or the privacy of the data. So under the FMU zip file, you have an XML format file which is called the model description file. So it contains the definition, okay, of whatever variables you're exposing, right? In your model, you'll have certain inputs and certain outputs, and also certain parameters which you have set inside. So all of these exposed variables, whatever you have set inside your model, they are given a particular definition in your FMU, and all the other static information like those parameter values or the parameter names, all of those static information will be stored inside your model description.xml file. Then you have source file. Okay, so the functioning of your entire model is made into a form of C functions. Okay, so in the language of C, all the functions are written down, and it all these C programs will contain model equations and also certain co-simulation tools. So no matter what function you have or what function block you have used inside your model, everything is condensed down into a form of C program, and this C program will perform same function as your that model file, and will give you the required output. Then we have binaries. Okay, so now I told you about working on different softwares, right? Now say your entire architecture of your system is different. Like say one team is working on Windows 32-bit, one more is working on Linux. That time what do you do? Then you can make use of the binary files. So under FMU 2.0 format, you have three options available. So one is Windows 32-bit, Windows 64-bit, and another one is Linux. These three binaries can be suited for their respective architectures, and that's how we'll be able to work with teams even having different operating systems. Then you have two more features of the FMU file: model.png, and if necessary documentation or index.html file. So model PNG is basically is not actually preferred, but if necessary you can have an image of your model enclosed inside your zip file, so that it can be shared with the concerned party if the transfer is necessary. Then the index.html file will contain some major libraries or dynamic links which will be utilized by the C functions which we discussed earlier, right? So inside that there will be certain functions which will be called upon, and those libraries or those functions be stored over here in index.html. To summarize, FMU is a zip file format which has basically 4 to 5 parts. One is primarily you have model description.xml, you have the source code or .c files, then you have binaries, and then finally you have documentation and an optional model.png file which has the model picture. FMU, and why do we use FMU? One thing is to maintain privacy of the data, so that you can wrap your entire model in the form of a black box, so that your client or the other party will not know what is there inside the box, but they'll be able to get the required output by giving the right inputs to that model. Then another use of having FMI is cross team collaborations. So team working on MATLAB, team working on Simulink. Team working on Simulink, team working on Open Modeling or LabVIEW. They can collaborate because we have the FMI standard. That's basically why FMI came into existence. All these different softwares, right? You needed some common base standard where you can work on, so that cross team collaboration can take place. And all these companies agreed to have one particular standard set in place to make this possible, and that's where FMI comes into being. Okay, so I think I have covered the basic concepts regarding FMI, and I think you have at least 1% of takeaway from this video regarding what FMI is, what are some of the basic parts of FMI, why did FMI come into existence, and yeah, I think now, if you can go into a little more detailed understanding, if you are willing to go into more detailed understanding, I think you'll have a better start than the rest of the people who have not watched this video. So yeah, thank you for watching this one, and I hope to see you guys in the next one. See ya.